Hydroboration oxidation of alkynes. Aldehydes and ketones can be prepared by hydroboration oxidation of alkynes. Terminal alkynes on hydroboration oxidation gives aldehydes. Non-terminal alkynes give ketones. Hydroboration oxidation of symmetric non-terminal alkynes gives only one ketone. What do I mean by symmetric here? Same number of carbon atoms on either side of the triple bond. If the alkyne is having same number of carbon atoms on either side of the triple bond, then it is symmetric alkyne. And so symmetric non-terminal alkynes on hydroboration oxidation gives ketone, only one ketone you will get there. Whereas unsymmetrical non-terminal alkynes. What are unsymmetrical alkynes here? Having different number of carbon atoms on either side of the triple bond. Unsymmetric non-terminal alkynes on hydroboration oxidation gives two ketones, a mixture of two ketones in which methyl ketone predominates. Now let us learn with one example. If I take 2-butene, if I take 2-butene on hydroboration oxidation. If it is hydroboration oxidation, what should be there on the arrow? B2H6 tetrahydrofuran THF, hydrogen peroxide and sodium hydroxide will be there on the arrow. So hydroboration oxidation means addition of water. H goes to one carbon atom, OH goes to another carbon atom. CH3C OH double bond CH3. This compound is enol. Enol tautomerizes. Enol tautomerizes to form ketone. So here we will get only one ketone. What is that ketone here? Butanone, 2-butanone. Now, let us take another example. 2-pentene. 2-pentene on hydroboration oxidation. So what should be there on the arrow? B2H6 tetrahydrofuran, hydrogen peroxide, sodium hydroxide. So in this case, addition of water takes place in two different ways. OH can attack second carbon atom or third carbon atom. If OH attacks second carbon atom, H attacks third carbon atom. So what is the product obtained? First thing obtained here, OH attacks second carbon atom and H attacks third carbon atom. You will get this one. If OH attacks third carbon atom, means H attacks second carbon atom. We will get these two enols. Enol undergoes tautomerization. If this enol undergoes tautomerization, I will get two pentanone. If this enol undergoes tautomerization, I will get 3-pentanone. But methyl ketone is the major product. So 2-pentanone is major product. 3-pentanone is minor product. This is about unsymmetrical alkynes. Unsymmetrical non-terminal alkynes on hydroboration oxidation will give two different ketones, a mixture of two different ketones in which methyl ketone will be the major product. Now let us see how to prepare aldehydes. Terminal alkynes CH3C triple bond CH means propyne. Propyne on hydroboration oxidation means B2H6 tetrahydrofuran H2O2 and NeOH. On hydroboration oxidation, so what will I get? CH3C. Hydroboration oxidation, here we have to follow anti-Markovnikov rule. Negative part attacks the carbon atom having more number of hydrogen atoms. So what will I get here? H here, double bond CH, OH. This is enol. Enol tautomerases to form aldehyde. We'll get aldehyde here. So terminal alkynes on hydroboration oxidation will give aldehydes. Now to avoid complications due to double bond addition, means here in enol there is a double bond here and it may again react with BH3 molecule. So to prevent that or to avoid the complications due to double bond addition of diborane, bulky sterically hindered boranes are used. I am again repeating, to avoid complications due to double bond addition of diborane of enol, when enol reacts with enol can again react with diborane. To avoid complications due to double bond addition of diborane, bulky sterically hindered boranes are used. What are bulky sterically hindered boranes used? First I'll give you the IUPAC name of that compound which is generally used. Bis 1,2 dimethyl propyl borane. Bis 1,2 dimethyl propyl borane is commonly used and which is commonly known as decimyl borane. Decimyl borane. So instead of B2H6, this compound should be there on the arrow. Means SiA2BH. This is represented by SiA2BH. Don't get confused with silicon here. SiA2BH is a representation of decimyl borane. It is representation of decimyl borane. So if decimyl borane is there on the arrow, we can avoid double bond addition of diborane. This is about hydroboration oxidation of alkynes to prepare aldehydes and ketones.